So hello grade 5 students, here we continue with our new lesson which is about the nervous system, part 3. Part 3 about the nervous system, we're going to talk about the action potential in nerve fiber. We said that we have 7 different phases of the action potential. So the phases of the action potential in nerve fiber, we have phase number 1, which is classified as the resting potential, where no stimulus is applied or obtained. Number 2, it corresponds to the hypopolarization, or it's called the artifact. Number 3 is called depolarization. Depolarization. And number 4, we have inversion of polarity. Number 5, we have repolarization going back to the negative. And number 6, we have hyperpolarization, so the negative more than the usual. And number 7 is called returning back to the resting potential. So let's start first, electric understanding of the rest. Depolarization. If we go back to the depolarization was phase number 3. We're going back to move to the positive depolarization phase. Depolarization, it corresponds to the hypopolarization. If you remember last time when we talked about hypopolarization, it's the decrease in the polarity, meaning that the decrease in the negativity, meaning that we are moving to the positive. So it corresponds to the hypopolarization of about 120 millivolt. So we moved from minus 50, as you see here, from minus 50 to about minus 70, sorry, to about plus 50. So we moved about 120 millivolt. And this indicates that the interior of the nerve fiber, it becomes more positively charged than the exterior, which become more negative. That's why we move to the positive, since the interior becomes more positively charged. Second phase about repolarization. Repolarization is going back to the negative. If you see here, phase number 5, repolarization, we're going back from the positive down to the negative. What happens during repolarization? It corresponds to the returning back to the initial state, where the potential difference drops from plus 50 to minus 70 millivolt. What does this mean? This means that the interior becomes more negatively charged again with respect to the exterior, which is more positively charged. Number 6, hyperpolarization. Hyperpolarization, hyper always, as I said before, hyper is increase, hyperactive. For example, Mr. Muhammad is hyperactive right now. So hyperactive meaning that it's very active. Hyperpolarization, polarization negativity, hyper, it's negative more than the usual. So it corresponds to the increase in the electronegativity of the interior of the nerve fiber. So where delta V, where the potential difference drops to minus 75. The normal case of the resting, it's minus 70. Where it drops to minus 75, what does this mean? This means that the interior is now more electronegative compared to that of the resting. So it's more negative compared to the resting, which is minus 70. That's why in phase number 6, we drop to the number 6, we drop below minus 70, below the resting potential. So here it's called hyperpolarization. It's negative more than the usual. Okay? While at the level of the ions, let's talk about the resting phase. As you know, the resting phase, the cell membrane is more permeable to K plus than to Na plus. So more Na plus, more K plus, sorry, will be in the inside, and more K plus will be on the outside. And this will explain this result. So in this state, in the resting state, the cell membrane permeability for K plus is higher than that for Na plus. So more K plus will enter and Na plus will go out. That's why it becomes, the interior becomes more electronegative. Depolarization. Here I'm talking, pay attention please. I'm talking about the understanding the ionic changes. Before, I'm talking about understanding electric results. Ionic changes, depolarization. Phase number 3. Which phase number 3? This is phase number 3. Phase number 3, this one, depolarization, going back to the positive, from the negative to the positive. What happens during the depolarization? During the depolarization, the membrane permeability for Na plus increases. So the more Na plus channels will open, and the permeability of K plus will decrease. So the K plus channels, they will close, meaning that Na plus, they can move to the channels. Their channels number increase, while K plus, their channels number decrease. So more positive charge will accumulate where? In the interior of the nerve fiber. That's why it becomes more electropositive, and that's why we move away from the negativity toward the positive, which is about plus 50 millivolt in this case. Okay, so here more positive charges will accumulate inside since the membrane of Na plus channels or the number of Na plus channels increase. So more Na plus channels will accumulate in the interior of the nerve fiber, and this will lead to the more electropositivity. Okay, repolarization. What the meaning of polarization besides negativity? Repolarization, they say, for example, start, restart. Polarization, repolarization, meaning that repolarization going back to the polarity. Here, the membrane permeability to Na plus will decrease. Na plus is responsible for the positivity, while K plus, whenever they open, they are responsible for the negativity. So Na plus channels, they close, and permeability to K plus will increase, so that K plus channel will open. So more positive charges will accumulate where? On the outside, and more negative will accumulate on the inside. That's why the interior becomes more electronegative, and that's why the repolarization phase corresponds to the decrease and the positivity toward the negative. Here, repolarization, you have to know that the sodium ion channels, they close repolarization, and depolarization triggers opening of voltage gated potassium channels. This one you don't have to study them, you have only to understand them. Part 6, hyperpolarization. As I said, hyper is more than the usual. Hyperpolarization, it's negative more than the normal. So the K plus channels, they are still open. They are too slow to close. So more positive will accumulate on the outside compared to the inside. As such, the interior becomes more electronegative, even more electronegative than the resting. It drops down that the resting state. Okay? You have to know that the potassium channels, they close. Repolarization reset the ion channels, and the ion diffuse away from the area. And sodium potassium transporter, it's called sodium potassium channels. It's called Na plus K plus channel is responsible for these changes. First of all, you have to know in the resting, you have K number increases and the potassium equal to 0. We have polarization. Number 2, whenever Na plus channels open, we have depolarization, moving away from the negative, move to the positive. Number 3, we have the K plus channels, they open. Number 3, that's why we dropped, it's dropped, the electronegative becomes more in the inside. Number 4, the K plus channels, they close relatively slowly, and this will cause the hyperpolarization. And number 1, it goes back to the resting potential. This is the same graph as the phases, but here I'm explaining it more and more. First, number 1, resting state is called polarization. Number 1, moving towards the negative. Number 2, depolarization, moving to the positive. Number 3, it refers to the repolarization phase, going back to the negative. Number 4, hyperpolarized, hyperpolarization. And number 1, going back to the resting phase. Pay attention to this note. First of all, we apply the weak stimulus below the threshold needed. Remember when we talk about the threshold. Pay attention here that the nervous system, all of them, they are connected to each other. They are connected to each other. Each part is related to the second. For example, part 1 is related to part 2. Part 2 is related to part 3. Also, part 3 is related to part 4 next week. So all of them, they are related to each other. You can't study one part and you leave the other. That's why they are connected, and I am dividing this lesson into different parts. So first, after applying a weak stimulus below the threshold value needed to trigger an impulse. For example, we need to trigger an impulse of a stimulus of 10 ampere. I gave you a weak impulse of 3 ampere, so there is no response. So it's called the resting potential. While after applying the stimulus above the threshold needed to cause the depolarization, and thus we have an action potential. So this stimulus is said to be effective. Why? It's effective since it causes the appearance of the action potential. While the first stimulus, it doesn't cause the appearance of the action potential, we remain in the resting potential. So this is referred to as ineffective stimulus. While number 3, stronger stimulus. So you have to know that the law that is obeyed by the nerve fiber. The nerve fiber obeys the law of all or none. Either we have an action potential or we don't have at all. So either we have an action potential here or we don't have at all. If you see here, these two, threshold, above the threshold and the stronger stimulus, both of them, they have action potential. If you look, mostly they are the same frequency, the same amplitude, meaning they're the same height. Okay, this is the meaning of amplitude, the same height. But here, it differs only with the frequency. Here, the response, it repeats itself only once. Here, the response, it repeats itself, or the action potential repeats itself by about 4 to 5 times. So it's related to the frequency. So here, you have to know that the propagation of the nervous message. The nervous message propagates in a unidirectional manner. It moves from dendrite to the cell body to the axon, then to the next cell, dendrite, cell body, axon, and then to the next cell, dendrite, cell body, axon. No nervous message, or none of the nervous message, they are going to move in this direction and in the other direction in the same way. It's not reversible. It moves in only in one direction. That's why it's called unidirection. For example, the nervous message can't move from the axon to the cell body to the dendrite. It moves from dendrite to the cell body to the axon. Saltatory conduction, we talk about this a lot, about the myelinated nerve fibers or myelinated axon. So the jumping of the input between the nodes of Frank. This is an axon, and this is the myelin shaft in yellow. These gaps, they are called nodes of Frank. So the message is going to jump. Jumping is called saltatory movement. So the nervous message was 2 meters per second without myelination. And with myelination, it's going to be about 120. So it's about 60 times larger than, or 60 times greater. Factors that affect the speed of propagation of the nerve fiber. Remember, when we talk about the factors, we have diameter, we have myelination, and here we have the temperature. Temperature number 1 is 20 degrees Celsius. Temperature number 2 is 30 degrees Celsius. So T1, T, temperature of nerve fiber 1, is less than temperature of nerve fiber 2. So the speed of the nerve fiber 1 is less than the speed of the nerve fiber 2. As a conclusion, as the temperature of the nerve fiber increases, the speed of the propagation of the nervous message increases. Drugs. Factors that affect also the speed of propagation of the nervous message, they are drugs. Drugs, they are 2 types. Either stimulants. Stimulants, they stimulate. They accelerate the nervous message. For example, I want to accelerate the nervous message. Sometimes they said, for example, Adam said, I didn't wake up unless I drink, for example, a cup of coffee. So this cup of coffee contains a stimulant, caffeine, that stimulates the nervous system, accelerate the nervous messages. That's where you wake up. Okay, this is acceleration of the nervous message. This is called the stimulant. While other drugs are called tranquilizers. Tranquilizers, they decelerate the nervous message, meaning that they make it slower. And these are example about them, sleeping pills. Whenever you take a sleeping pill, your body activity will decrease since the nervous message speed decreases, and you will go to bed and sleep. Okay? This experiment talking about the pathway of the nervous message, we said that we have sensory, then afferent, then we go to the associated neuron, or it's called interneuron, then to the efferent neuron, toward the effector organ. This experiment is about Magendie experiment. Magendie experiment, I'm going to talk about this in details next week, about Magendie experiment and what happens during this experiment as well. Okay?